In question number 4, example 4, it is given that in a triangle ABC, the bisector AD of angle A is perpendicular to side BC. The bisector AD of angle A is perpendicular to side BC. Then we need to prove that. First we will write the given part. This AD bisects angle A and this AD is perpendicular to BC. We need to prove AB is equal to AC and ABC is isosceles triangle. See, if we prove AB is equal to AC, that makes ABC as isosceles triangle, obviously. So, how we can prove this? Same thing. AB is equal to AC. Sorry, AB is equal to AC. Then, okay. Then, how this can be proved? We need to prove, this is enough to prove that the triangle ABD is congruent to triangle ACD. How to make these two triangles congruent? Is, we obviously know AD is common. AD equals AD, that is common side, and then the bisected parts of A, angle DAB equals angle CAD. That one how we can write? From the given thing, because this bisects, and then as this is perpendicular, we can say this angle ADB equals angle ADC, each 90 degree. Now what congruency rule will be applied? ASA, because the side is common for these two angles. So by ASA congruency rule or axiom, you can say this triangle ABD is congruent to triangle ACD. Then we can say this AB is equal to AC by CPCT, or ABC is isosceles triangle. That is it. Next, example 5. What is there in the example 5? E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. Quite confusing, right? E and F are midpoints, respectively the midpoints of equal sides of a triangle ABC. So, there is a triangle which is called ABC, in which AB and AC are equal and E and F are midpoints of them. We need to show that BF is equal to CE. So, BF means this B connected with F, C connected with E, that is equal. We need to prove. So, first we will write the given parts. Given E and F are midpoints. AB and AC such that respectively. Also, AB is equals AC is given. The triangle is isosceles. That is also mentioned in the question. Oh no, not mentioned. Just they mentioned these two sides are equal. Now, we need to prove BF is equals CE. Okay. Then, how this can be proved? Whenever two angles or two sides like this equal, we need to prove means, first we have to observe the triangle which has this BF and CE as sides. See, BF is a side of a triangle, like BFC we can take, or else BFA we can take. Which one would be helpful for us? Either way we can take. So, if we take BFC, it is enough to prove triangle BFC is congruent to triangle BEC. Okay. How that can be proved? We have BC as common side. As you can see clearly, BC is the common side. So, the side BC is equal to BC because it is common. Apart from that, any other things are common? We can say EB is equal to FC. Why EB is equal to FC? EBE is equal to CF. So, I think we wrote this wrongly. BFC means BC should come equal. Also, this BE is equal to CF, right? CFB will write. Then it would be fine. BE is equal, CF is equal to BE. This triangle CF. It is enough to prove this triangle CFB is congruent to BEC. Okay. See, CF is equal to BE, which means that is halves of equal sides. Since E and F are midpoints, or simply you can write given. Also, is there any other things we can say? The angle B equals angle C. Why? Because these are angles opposite to equal sides. Because in the question itself they gave AB is equals AC. Okay. Then what congruency rule applied? What congruency rule? SAS congruency rule. You can say this triangle CFB is congruent to triangle BEC, and that makes BF is equal to CE. Then BF is equal to CE by CPC. That is all. Also, when you see the same proof in your book, is that same or different? Same. Yes, different triangles. In your book, they took AEC and AFB. Okay. So, in your book, they took different triangles. We took different triangles. So, what we done is wrong. Is that wrong? Either way we can do. Okay. The thing is that the answer should be reasonable, that should be correct. That is all. Then next one, example 6. Can you read the question and tell me how to prove that? Example 6, that says, in an isosceles triangle ABC, ABC is isosceles triangle, and with AB is equal to AC, D and E are points on BC, D and E are points on BC, such that BE is equal to CD. This part and this part is equal. We need to prove that AD is equals AE. AD means this one, AE means this one. First we will write the given part. I am waiting for your answer, boy. Tell me the answer. Just tell me how to do this. Don't see the proof. Don't see the answer. Just think by yourself and tell. Triangle ABD is congruent to ACE. How to prove those two triangles are congruent? BE is equal to CD is given. We need to prove AD is equal to AE. To prove that, it is enough to prove triangle ABD is congruent to ACE. Tell me, boy. Just list out the common things, man. AB is equals AC because that is given. And then any other things can you say equal? You just ignore these two lines and say angle B is equal to angle C. Why? Angles opposite to equal sides. And then only two things we have equal. See, we have this BE is equal to CD. Will that help? No. But somehow it will help. You remember that question? See, this like one is there, this angle and this angle we have. This middle part we took it common and we added that on both sides. Likewise, we have a common part here. See, we have this BE and the CD are equal, in which both are there, both things DE is common. Shall we add or subtract DE to get the things that we wanted? Add or subtract, I am asking. Subtract. So, subtract DE on both sides. Then we can have BE minus DE, CD minus DE. BE minus DE will give you what? BE minus DE will give you BD. Am I writing the corresponding sign? Yes, BD equals CD minus DE will give you EC. ECE or EC. Okay. So, we have one angle and the two sides equal. We should make sure that that angle lies between the two angles. Every time I am saying this. Why I am saying this? Because sometimes what happens means two side and one angle may be equal. But the thing is, it may not be lies between those two sides. You need to make sure that. That is why every time I am telling. So, two sides and one angle, will that angle lies between the given mentioned two sides or not? So, BD, AB, yes, it lies between those two sides. EC and AC. Yes, it lies between the mentioned two sides. So, we can say by what congruency? SAS congruency rule. This triangle ABD is congruent to triangle ACE, which means by CPCT, then we can say AD is equals AE by CPC. That is all. Now, without doing this subtraction things and all, is it possible to do the question? Yes, of course it is. You think, see, instead of taking this small parts, if you have taken this whole part means, would that be helpful? Yes, of course, but it would be harder to differentiate these two triangles. See, this triangle ABE and this triangle ADC. If you take these two triangles, these two sides are already equal, these two angles are already equal, and we have this yellow color line BE is equal to this pink color line CD. Same SAS without subtraction. Possible or not? Are you getting confused or are you getting the clarity? See this yellow color triangle, can you see? ABE. I'll write for you, see. ABE and this triangle ADC. I am taking. In that AB is equals AC already given in the question, and the angle B equals angle C. Sides opposite to equal angles. This BE is equal to CD given. Now what congruency will apply? Same essays. This subtraction happened? Never happened. That is it. Shall I erase?